HPC, which is what we've been talking about so far today mainly. And I might sneak in another buzzword, serverless. I was going to sneak in unikernels as well, but I won't. So then, anyway, that's me. That's where I work. The probably interesting thing there is that was 650 million when the pound actually had some value, which it doesn't anymore. Yeah, okay. So the first point to make is that I think, in my experience, the traditional model of HPC, where you've got a big cluster, it's quite expensive, you've got maybe restricted set of users, that's coming under increasing pressure from funding bodies. So in the past, I've had to do cost comparisons of would it be cheaper if we did this on AWS or Azure or Google Compute. So funding bodies are complaining. We also see that kind of complaint inside organizations. Again, they're on the golf course and they hear about the cloud and say, why can't you use the cloud? Isn't that cheaper? And then you get research groups who they've got a 3-year project, and then with 2 months to go, they suddenly need to analyze all their patient data, and they need 10,000 cores to do it. And you're not going to procure a new 10,000 core cluster in 2 months. So can we use the cloud? An example of a cloud that I work on is eMedLab, which is a biomedical research cloud. So that's the only sort of workload that we have on there. 6,000 cores, 5.5 petabytes of storage. It's a consortium of organizations around London and Southeast England. And one of the guiding principles is that the data methods and expertise must be shared amongst the users. It's using OpenStack and GPFS. Oops. So GPFS is a very traditional sort of fast file system that you would find in lots of HPC clusters along with Lustre. But it assumes you've got a nice friendly environment where it's okay to have root SSHing between all the nodes, which is not really what you would expect on a cloud. It also has complications with the licensing. So if you wanted to get around that, wish to isolate yourself from potentially malign cloud instances, maybe you would try and run a server on the hypervisor, but then would IBM be happy with that kind of licensing? Maybe, maybe not, but probably lawyers would be involved, and that means a bit more money. So the way around it that we have at the moment is just exporting over NFS, and I know that the CLIMB project, which is a microbial bioinformatics project in the UK, has also had to do the same thing. So you're kind of losing a lot of the performance that you gain by having GPFS in the first place, which is a bit of a shame. But this access to shared data is a founding goal of the project, and it's what people need. It's not just when they're writing their data. They need to refer to things. There are these very large, publicly curated data sets that the jobs need to refer to when they're running. But the cloud person would say, why don't you use an object store? They're much more scalable, much more sensible. But if you can find bioinformatics code that supports objects, then I'll be very happy. They don't really exist. An example that I worked with is an 800 terabyte data set from TCGC, which is the Cancer Genome Consortium. So this is, because it comes from patients, you have to apply for access to the data. So we have to be extra careful on who within the project can see it. And helpfully, you can only download it via a special client, which is really weird. And we actually had to, via trial and error, work out how many instances we needed to run of the client to download it in a reasonable period. I think we had to run 12 instances in parallel, and it took us 2 weeks or something. So it's quite a pain to deal with data sets of this size on clouds. So when you've got your data, what are you going to do with it? What we've found is people want to run virtual clusters. That's what they're used to. So they use things like Elastic Cluster, or if they've used clouds before, they might use Heat or CloudFormation, or maybe they just create a cluster using Ansible or Salt. But again, you've got the problem of shared file system access. And I think the question arises to me, is that actually the best way of using a cloud? Is it? are you really getting the benefit from a cloud? You're going to start up a load of instances which may not be doing that much a lot of the time. Wouldn't it be better to get to know your pipeline better? And maybe there's one step where you're hardly doing anything, but then you need to spin up another 10, then get rid of the 10, get another 5. But people don't tend to know their pipelines in that level of detail. And I think the reason that people sort of rely on this crutch of the cluster is it goes back to the mindset that you have of, oh, you've got a cluster, it's got to be used all the time. You've got to have sort of 90% utilization of your cluster, irrespective of whether you're actually doing work that's worth doing. So conversely, you get people who get frustrated by some of the performance disbenefits that you get with clouds because of all the layers of indirection in the I/O. So then they heavily tune it, particularly the network stack, but then you lose things like live migration, again, one of the benefits of clouds. And I think you also, when you're going down that road, you lose the flexibility and the kinds of workloads we're talking about in this room today, the big data workloads, the increasing wish that people have to integrate, say, in my field, you might have sequencing data, and maybe you want to integrate that with mass spectrometry data, with electron microscopy data. So what is more important there, I think, than the raw sort of single-threaded performance is getting the software working together. That's the sort of time gain that you're going to get, I think. I've also found that people are particularly focused on snapshots. As soon as they've got something working on the cloud, they say, okay, can we make a snapshot of that just in case it goes wrong? But then what are you going to do with this snapshot? What if there's a bug in OpenSSL, as if that could ever happen, and they need to upgrade it? Who's keeping track of which images are being used where? Who really knows what's inside the image? Wouldn't it be better if you use some kind of configuration management to build it? And I've seen, I was at the OpenStack meetup in London this week, and people were criticizing OOO because that's image-centric. They were saying, we'll just use OpenStack Ansible instead. I think I've said all that already. So this is a slide that I'm quite happy to nick because it, turning into microservices, which is what you're supposed to do for containers, if the input is not good, the output may not be good either. So I think it's very good that we in this community look outside ourselves for fertile ideas, but bear in mind that the mindset that people have in these startups in Shoreditch and the constraints they have is very different from what we have in the scientific community. How mature is the support of scientific applications in containers? I mean, Singularity and Shift are very good projects, but with things like the Docker file and the Singularity files, are they really great formats for describing what you need? Maybe, maybe not. And aren't containers a bit rubbish anyway, because you still need to run a server, and who wants to do that? You should be using Apache Lambda, Google Cloud Functions, or OpenWhisk and Fission. But I don't see any input from the scientific community into those yet. So I think we need to start engaging with the serverless developers. And as a counterexample to all that doom and gloom, in my previous job at Imperial College, when I was working on the CMS experiment, when they had cloud resources, because they had a very mature environment, that's nice, we've got 13,000 cores, we can use those, because they've already got all the tools to move data around, to keep track of what data is where. They've already got accounting tools, so they know which users are running what. And there were some concerns about security, as in when you need to ban a user, how do you know what they've been running where? But they were actually able to make, and are still making, very good use of cloud, so it is possible. That's it. Thank you.
Every lightning talk gets one question. So one question, and the lucky winner gets picked by the speaker. So any questions?
It's a very good Riley book called Infrastructure as Code. It's probably on the standout side. And the guy who wrote that makes the same point. When virtual machines came along, it actually made system admins like more difficult because there are thousands of specialist VMs to keep track of, and yeah, they say you should be going towards reproducible. So
Yeah.
that's cool.
All right, so thank you.